We will discuss about an exciting service provided by AWS for developers, that is API Gateway. Before we jump into the service, let's first see what APIs are. I know many people are familiar with APIs, especially if you are a developer, but please bear with me for a couple of minutes for the sake of audience who are not aware of what APIs are. Let's say you are a developer and developed a cool and awesome application, let's say in C++ programming language. You have demonstrated this to your friends or colleagues who are also developers but in different programming languages. Let's say they want to use your application in their programs and provide same features to their customers or do whatever they would like to. Now, these programming languages are different and cannot talk to each other, right? To make this possible, APIs are born. Well, API stands for Application Programming Interface. APIs help different applications with different operating systems or programming languages talk to each other and share information across platforms. Well, a few examples are Twitter feeds or Google Maps, or Facebook posts, which are available over public APIs, provided you are authorized to access them. Now, let's talk a little bit about the history of APIs. Origin of primitive API-like functionality was developed in early 1990s, which is called as RPC, which stands for Remote Procedure Calls. They are used to communicate between multiple computers connected over a LAN network via sockets. Well, sockets are a channel to allow or send requests from one computer to another. Well, this is between computer to computer, you can see from the diagram. So, what if we want to communicate between multiple applications which are over the internet? Then came the origin of SOAP web services. These prevailed for a long time. They basically communicate over HTTP traffic using a protocol called SOAP. In here, the client and the server will share a common information file called as WSDL, which stands for Web Service Definition Language. It is basically an XML with all the API information. And the client here also needs to have a SOAP client library in order to make requests to the server. And then the latest standard for APIs is REST. Well, REST is not a protocol like SOAP. It is just an architectural pattern and it also communicates over HTTP traffic. Servers will have REST endpoints over which clients can send requests by sending data in an XML or JSON format, and the server will also respond back in XML or JSON format. Well, there are various reasons that REST has been widely used and adopted by many application developers. Well, that's for another day to discuss. But the main reasons are that the performance improvement over SOAP web service and the simplicity and ease of development for the app developers and API developers. Okay, now let's talk about API Gateway from AWS. It is an AWS managed service to create, publish, maintain, monitor, and secure your own REST and WebSocket APIs at any scale. Well, you might be wondering, where is SOAP in here? Well, API Gateway does not directly provide any option for SOAP APIs, but SOAP requests and responses are also XMLs with certain additional information. So you can use REST APIs to send and receive SOAP requests. And then it handles all the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls, including traffic management, authorization and access control, monitoring, and API version management. So you don't have to worry about the infrastructure to handle these requests at scale. With API Gateway, you can create robust, secure, and scalable APIs that access AWS or other web services as well as data stored in AWS Cloud, which means you don't have to create APIs anymore at your application level. You can make use of API Gateway to create all the API endpoints easily, which can handle any scale of requests. This helps you concentrate more on your application development rather than spending a lot of time on developing APIs. And also, API Gateway plays a major role in building serverless applications. You can use API Gateway in conjunction with Lambdas or DynamoDBs or S3 to develop a full-blown serverless web applications. API Gateway provides an endpoint in this format, which is your app ID and then the execute API, and then the region in which you created your APIs, and then Amazon AWS.com. Well, you can use Route 53 if you want to use your own domain name and then redirect requests to this endpoint. And different types of endpoints are edge optimized API endpoint. This is the default API gateway host name, which makes use of AWS CloudFront edge locations to improve connection time for geographically diverse clients by caching the requests and responses on the edge locations. Well, if you're not familiar with AWS CloudFront, please look at our lectures on CloudFront. It is a very important service for the developer and associate level examinations. And next is private API endpoint. It's basically exposed through interface VPC endpoints and allows a client to securely access private API resources inside a VPC. So private APIs are isolated from the public internet and they can only be accessed using VPC endpoints for API gateway that have been granted access. So this will be very helpful if you want to develop APIs only within your organization. And next comes the regional API endpoint. It is also a host name deployed to a specific region and can be used to serve clients within the same region. Example, EC2 within a VPC. So this does not use CloudFront distribution to route traffic through edge locations. Well, this is useful if you definitely know that the API will only be accessed within a specific region. So this avoids unnecessary round trips via CloudFront edge locations and even saves some cost. Now, let's see how API Gateway works. In traditional approach, if you want to access an application, let's say developed in Java from various different applications such as laptop or mobile phone or tablet or even from different servers, you would have to develop APIs yourself, typically REST APIs these days. So this would be another layer on top of your application in terms of infrastructure or scaling requirements or development efforts, etc., where you need to invest a lot of time and money. And on top of it, you would have to secure your APIs via a firewall. Now, what if you get this piece as a managed service and you don't have to develop code or manage any infrastructure or worry about scalability? This is what exactly AWS API Gateway gives you. With API Gateway, you can create an API endpoint within few minutes or maybe few hours. So once you create an API, you need to define a backend service to which you need to redirect the request to. API Gateway can send requests to multiple AWS services such as AWS Lambda functions or EC2 instances or S3 or DynamoDB, etc. You can also send requests to private EC2 instances inside your private VPC, or you can even send requests to an on-premise application on your data center. For APIs built on API Gateway, you can send hundreds of thousands of requests at any scale without thinking about the underlying infrastructure. So once you start using API Gateway, you never have to develop APIs on your own. All right, we will discuss more details about how to create APIs, what are its different components in our demo session. Thanks for watching. Hello and welcome back. In this session, let's take a look at how to create REST APIs using AWS API Gateway and how to build a serverless API using DynamoDB and Lambdas. All right, let's get started. Let's search with API Gateway and click on it. This is a landing page for API Gateway. AWS provides a sample API for you to understand the gist of it and play around with. This is just a mock service. It does not have any backend, so feel free to play around with this mock service. For our demo, let's create a new API from this button, Create API. From here, you can choose which type of API you would like to create, REST or WebSocket. Let's choose REST as it's more widely adopted these days. And this section provides different options to create the API. You can either create a new API from the scratch, or you can clone from an existing API. This option is helpful if you have a skeleton API which would be used across all the APIs you built. This is a usual practice to create a framework if you have multiple APIs to be built, so that you follow the same standards and don't have to rework on creating the baseline again. And you can also choose from a Swagger or Open API file. These files are basically a JSON definition file which defines your APIs. You can import the file and API Gateway creates an API for you. Well, I'll show you how to do this in later part of the course. And you can also create an API from this example API, which is the one we saw in the previous screen. Okay, all right, let's create an API from scratch. So let's choose new API. Let's give it a name. And here are the endpoint types, the ones which we discussed in our API Gateway theory lecture. So let's choose Edge Optimized and click on Create API. The API has been created. Every API will be assigned with a unique API ID as shown here. Okay, we have this whole bunch of options for an API. We will go through them later once we have seen how to create resources first. Well, some people call these resources as endpoints as well. API Gateway named them as resources. It's all one and the same. So let's click on actions in here and create resource. You can define the API hierarchy structure in here. Let's say you want your URL to contain certain prefixes, let's say API, and then the version number, and then you will have your resource names such as users or departments or etc. We can create that structure in here. So let's give the name as API. This will act as a root path for this API. Let's click on create resource. And then you can create child resources under this, and you can create multiple level deep hierarchies based on your functionality. With this one, let's try to fetch bucket names in my account. So let's name it as my buckets. All right. Now, if you want this resource to be your API endpoint, we need to create a new method under this. So let's go to actions. And this time, let's create a method. Well, a REST method should contain any of these types. We want to list buckets, which is a get operation, and we are not submitting or posting anything. So let's choose get. All right, these are the list of integration types, the backend for API Gateway to forward the request and perform the actual logic. Well, we have Lambda function, which we will visit later in the course. And then we have HTTP option, wherein you call another endpoint, probably a REST service, located in your on-premise data center or in any of your VPC EC2 instances. And then we have mock option. It doesn't make any request to backend services. It just returns a sample mock response. And then we have AWS services. Under here, you get to choose the region and the service which you would like to invoke when a request is made to this API resource. We can leave this subdomain field blank. A few of the services have subdomains. You can visit AWS documentation if you would like to know which services support subdomain. And under action type, you can either give the action names for the selected service, let's say describe instances or list objects from S3, etc. Or you can choose use path override to provide the REST path provided by AWS to call a particular action, something like this. Let's say example bucket slash abc.txt. And under execution role, we provide the role which will be used to make requests to the selected service. So ensure you have provided appropriate permissions for this role. And the last one is VPC link. As discussed in our theory lecture, we can also make requests to apps within a private VPC, right? This is the one I was talking about. So we first create a VPC link and then choose the VPC link in here. And then you can provide the private endpoints in here, which is running on probably an EC2 instance within your private VPC. So using VPC link, you can privately connect to apps which are built on your private VPCs without exposing them onto internet. I will briefly talk about how to create a VPC link later in our courses. Okay, since our resource in here is about listing buckets, I will choose AWS service and then the region as US East 1 and then the service as S3. And the method will be get, and action type, I will use action name, and the action is list buckets. And for the role, I have already created this role and provided appropriate permissions to access S3. So I'll paste it in here. We are seeing this content handling option in a lot of places, and you might be wondering what it is. Well, this defines how we should send the request we receive to the backend service. Pass through means it sends the request as is. You can also convert the request to binary or plain text, but for now we will leave as pass through, and let's save this. Okay, in here we see a simple kind of data flow diagram, how the request and response flows between client, API gateway, and the backend service. You can also perform quick tests from here to see if the API resources are working. So let's click on test in here. You can provide any input path parameters if you have defined in the resource, or query string parameters to send them across to the backend. Let's leave them as blank for now and hit test. And there you go. The response status code is 200, which suggests the request was successful, and the buckets from my account in XML format. Well, what we have done here just now is just testing within API Gateway. The service is not yet available for anyone to consume. So in any typical applications, once you develop the application and if you want to make that available for your users, what would you do? You would deploy your application, right? Yes, that's what we will do here as well. So we need to deploy this API for this to be available to be consumed by all of your users. So let's go to actions and click on deploy API. When deploying, we need to choose a stage. A stage represents lifecycle state of your API. These are kind of different environments such as development, test, and production. You can configure different settings for different stages and control access through API Gateway Resource Policy. So using stages, you can segregate and isolate your APIs and the requests sent to the APIs. So let's create a development stage, and you can provide the stage description and deployment description. Well, it's a good practice to provide meaningful description for each deployment so that you can track the changes in future. Let's click on deploy. So here is the stage, and this will be our root URL for this stage. And you can also see all the resources from here. So if we go to our resource, you will get the resource specific URL. This is a URL you can share with your consumers. Let's open this link in another tab, and you can see the response with all the buckets. Now your API is available for consumers to use. All right, now we will see how we can build a serverless API which you can consume from web resources such as JavaScript, which are hosted on S3 static website to make a fully blown web application. But in this session, we will only build API though. Entire application will be for another day to discuss. For this purpose, I have a sample table in DynamoDB. Let's take a look at it. Search for DynamoDB and navigate to tables. I have this users table, and if you look at the items, I have a few records in here. In our API, let's try to get a user based on the user ID, and we will also create a new user. Okay, from the API, although we can directly read and write data to DynamoDB using AWS service option as the backend, that's a crude way of doing it. We will usually have application layer where you will have all the logics written, right? So which service in AWS fits into this space to make the application serverless? Yes, that is AWS Lambda. I've written a couple of functions, one to get data from DynamoDB and one to put data into it. So let's search for Lambda. This function in here is to get users. So let's click on it. All right, this is the code. It is in Python and it is fairly simple. This line in here gets the user ID from the path parameter if it exists. Otherwise, it will return an error to API Gateway. And this line in here is to instantiate the DynamoDB client. And then we instantiate table object with our table name. And finally, we call get item action on this table by sending user ID to filter on. If we get response, we will return the user record. Otherwise, we send an appropriate error back to API Gateway. One thing to note in this return response is that it must have these keys, status code and body. and the body must be converted into a JSON string. Otherwise, you will get errors when invoking this function from the API gateway. All right, let's go back to API gateway and create a new resource and invoke this function. Let's add a new resource under API here, and let's name the resource as user. For our Lambda function, we need to send user ID as input via path parameter, right? Path parameter is basically a child resource for this user resource. So let's add a new resource under user, and we can add path parameter in this format with curly braces. Let's create resource. And for this resource, we will add a method. So let's create method this time and choose method type as get. So in the previous resource, what we created for the bucket, we directly created a method under the resource called myBuckets. But in here, we created another level of resource for the path parameter, and under that, we are creating the method. So don't get confused with this, because the path parameter would also be an additional child for the resource. So if you are providing a path parameter, this is how we do it. For integration type, let's leave the option as Lambda function. Let's get the Lambda function name and paste it in here. This checkbox in here, use Lambda proxy integration, is to send entire request as event to the Lambda function. If you know Lambdas, event is one of the input to its function, right? So let's just print the event to see what information is being sent. We can check the CloudWatch logs once we make the request. So let's go back and check this checkbox, and let's save it. This pop-up is to grant access for our API on the Lambda function. So let's hit OK. All right, let's test the resource from here. And let's provide a value under this path parameter user ID and click on test. And there it is. We got a successful response with status 200 from our Lambda function, and which in turn fetched the user information from DynamoDB. And if we test with a user ID which doesn't exist in the table, let's use value 10. And we receive an error from our Lambda function. Well, we have made a couple of requests. So let's check the logs to look at the request sent via event. Let's go to monitoring, view logs in CloudWatch, and let's pick the latest log stream. And here is our logged event. You can see the path parameters, request context, and you will also have body if this is a post request, but you don't see it in here because it's a get request. All right, let's also add a method for creating a new user. We will use the same resource, but add a new method to it. Well, this is a usual practice in REST implementation wherein you will use the same resource type, let's say users in our case, and we will just create two different methods, one for get and one for post. So let's create a new method under user resource, and this time let's choose post. So this time we are creating directly under the user resource because we don't have any path parameter in here. So we don't need an additional child under user resource. And integration type as Lambda again. And this time let's pick the put user DynamoDB function to be invoked. This is also the Python code. In here, we are making sure we received all the request parameters in the event body. If we don't, we just return an error. And if we do, we instantiate DynamoDB client and then call put item action on our table with all the inputs. And once inserted, we send a success response to the API gateway. All right, let's copy the function name and go back to the API gateway and paste it in here. And check this checkbox to send the request as event. And let's save. Click OK to grant access on Lambda function, and we will quickly take a look at what exactly happens when you click OK in here. So let's go back to the Lambda function. If you click on this key icon, you will see the Lambda function policy and role policy. When we clicked OK on the pop up screen before, it added this policy statement to the function policy to grant access for API Gateway service if the source request is coming from this API resource. So we have created the post method. We can start making requests to this. But what if the request body doesn't contain any valid input parameters? And what if there is no request body at all? Well, from our code, we already handled input checks, which should always be done as a best practice. But what if there are malicious requests or any request being sent on error? Sending all such requests to Lambda might choke your account's concurrent limit and might incur costs for Lambda executions. So, API Gateway lets you define the structure for your request body using JSON schema with something called as models. Models can also be used for the response payloads coming from the backend. So let's first create a model for this resource request body. Let's go to models and create model. Let's give it a name and content type. We will be using application/JSON. And let me quickly write the schema. All right, here is the schema. This follows typical JSON schema reference. Well, in short, this defines the input object you send should be of this structure with the following keys whose values will be strings. And the required parameter here dictates which keys in here are mandatory, without which the validation would fail. So let's create the model. And let's go back to our post method. And under request body, let's add a model here. Content type as application/JSON and choose our new model here. Okay, although we have added the model here, the default request validation is not set. So we need to enable this for validation to take effect. You can choose what exactly needs to be validated. I will choose validate body, query string parameters, and headers. All right, let's go back and try to test this service now. Let's provide some inputs and see if the validation works. I will just give two inputs for now. User ID, the value as 10, and first name and the value as test. And let's hit test. Well, the request validation failed, although we provided the input. Why? That's because we had a required field in the model, remember? So the request is missing those fields, and so the validation failed. Let's provide all the inputs and click on test. And the request was successful. Status code 200. So this time the request validation was successful and the request has been sent to Lambda, and Lambda executed its functionality and inserted a record into DynamoDB. So let's go back to DynamoDB and refresh the items in here. And there is our new item. All right, we have created the required API resources and tested internally. But remember, these are not yet available to be consumed. So what should we do next? Deploy the API. So let's go to actions, click on deploy API. This time, let's say we are all done and ready to deploy to production. So let's create a new stage, name it as prod, and give some stage and deployment descriptions. Here is our prod stage and ready to be used. Let's quickly check if we can use our new serverless API endpoints. So let's grab our users get endpoint and access it by providing different inputs. All right, it works perfectly. Let's also test our post request. Well, for post request, we cannot send the body from the browser. So I'm using a Chrome extension called Postman. It is a REST client. You can use whatever you're familiar with. All right, let's paste the endpoint in here, change the method type to post, and add content type header and value as application/JSON. And here is the input request with user ID as 11. And let's send the request. and it was successful. Let's quickly check in DynamoDB, refresh items, and there is our new record. Perfect. We have successfully built serverless API using AWS API Gateway. All right, this is long enough for one session. We will discuss about various configuration options for the stages as well as for the entire API Gateway service in our next lecture. Thanks for watching.